All right, in this video, we're discussing the concept of relative frequency. So as we saw before, when you have data organized into a frequency distribution, you have this column that gives you the frequencies, right? It tells you how many of your observations fell within this range of values. However, there's a better way to represent the frequencies, and that is to use relative frequency. So there are two major reasons to use relative frequency. One that we'll discuss later is that it's going to help us create graphs. So it's nice to have the relative frequencies as opposed to the raw count data. So rather than just use the frequencies, the relative frequencies will work better in most graphs. Now, the other thing that I think is the more important reason is that it's easier to compare two different studies that have different sample sizes that are on the same topic, right? So for example, if there was somebody else that did a study on the cost of restaurant meals in this particular city, but maybe they used a totally different sample size, then it's much easier to compare their results with the results of this study if the results are expressed in terms of relative frequency, right? Because relative frequency is the same as proportion, or you could even convert it to a percent pretty easy. For example, this 0.36 value in the middle of the table here, move it over two places over, it becomes 36, or in other words, 36%, right? So you can convert these relative frequencies to percents just by multiplying by 100 or just by moving the decimal point over two places. So what we're saying here is roughly 36% of the meals in this study cost somewhere between $32 and $40, right? So they might have been $32, it might have been $35, etc., right? But either way, roughly 36% of the observations fell within that category. If I went and told somebody that, hey, there was a study and 18 of the meals they looked at fell into that category of $32 to $40, what does that tell you? It all depends on how many observations were made, right? I mean, if they looked at 500 restaurants and 500 meals, then saying that only 18 fell into that range, is okay. It's a tiny amount, right? So we don't have to worry about it then. It's not too expensive to go out and eat in that city. But here instead, we're saying to someone, 36% of the meals fell within that range. Now you're like, oh, wow, okay, that's more than a third of the meals in this city out at restaurants cost between $32 and $40, right? So now, hey, that's a lot more eye-opening, right? Because you say, oh, geez, 36%, more than a third, right? That's a lot. If I just tell you 18, the next question you're going to ask me is 18 meals out of how many did you look at, right? If it's out of 1,000, not a big deal, right? Out of 500, not a big deal. If it was out of just 36 meals, a very big deal, right? So the point is that we need to have relative frequency to kind of make intuitive sense of things, right? And then, of course, you could then compare this to another study, because another study, if they also, reported the data in relative frequency or in percent terms, if you found out that they found that 40% of the meals are in that range, and here you found 36% of the meals in that range, you say, okay, that's pretty comparable. So the studies are kind of showing the same thing. All right, so that's generally the idea behind relative frequency.